All right, we're looking at probability part 3, and we're going to start with this question. It's pretty popular in the area of probability and statistics, and it's called the birthday paradox. And so we're going to look at this question. Can you make a guess as to what you think the probability is that two people in this class share the same birthday? Would you want to make a bet that two people share the same birthday? I think it's highly likely or unlikely. Really, that's for you to think about. But let's start with the easier problem. If the event's two people in this class share the same birthday, then what's the complement of that? So if two people share the same birthday, how about complement of that would mean no one shares a birthday. So we're going to think about that a little bit. There's a little box here from our textbook that talks about the complement of an event being that the event E doesn't happen, and we'll often denote it with a little bar on the top for the complement of whatever event E is. We can compute the probability of the complement by using 1 minus the probability of E. So remember that the total for all of our probabilities is always equal to 1 or 100%, we'll sometimes say. It's always some number between 0 and 1. And so it works the other way too, that if you're looking at the probability of an event, you can look at 1 minus the probability of its complement, okay? So we're going to think about that a little bit, but first it says the dates on which people are born are independent. We want to calculate the probability that two random people, you and a random classmate in the class, share the same birthday. Now, that's a pretty straightforward calculation with two people. Let's see. Basically, if there's just two people, that person has a birthday. Now, the probability that this person shares the same birthday, well, it would depend if they had that one particular date that their classmate did. So the probability of that happening is 1 out of those 365 days, which is about 0.027, so about 2.7%. And I hope that makes sense. It should be kind of small, but also not like smaller than 1 so much, because there's only 365 days in a year. That's not very many days to choose from. So now let's consider 3 people, and I'm not going to draw them this time, but let's think about the different ways that at least 2 people could share a birthday. So it says think about like A, B. So like if person A and person B, they might share a birthday out of the group, or it could be B with C, or maybe A and C, or maybe all 3 of them have the same birthday, because it just says at least 2 people. So it could be that the 3 of them all have the same birthday. So if we want to calculate the probability that 2 out of 3 share the same birthday, it says that we need to find the probabilities for each group in the prior question. So if we know that the probability that those first 2 share a birthday is 1 out of 365, well then let's consider these ones. That would be 1 out of 365. And then those 2 sharing, that would be 1 out of 365. And then all 3 of them sharing, well, for that one, we would have the 1 out of 365, but then the next one, we would want, their probability would also be 1 out of 365. So we're looking really at 1 out of 365 times 365. That would be that all 3 would share the same birthday. So when we add those together, it ends up that it's going to be equal to 0.0082, about. So I'm gonna round it off there, about that much. So let's think about another way, because you're gonna see that it kind of gets harder as you get more and more people. But it suggests that we could find the probability by using the complement of the event. So if we have those same 3 people and we want to suppose that they do not share a birthday. So let's think about that they do not share a birthday. So there are basically 365 ways for the first person to have a birthday out of 365 days. But the next one, if they don't have the same birthday, there's only 364 days to choose from. And the next one also can't have one of those birthdays. So that would happen 363 out of 365. So this is the probability that no one shares a birthday out of those 3 people. And so if we want to find the probability that at least 2 do, then we're going to do 1 minus that. That's where that complement comes in. And when you calculate that, punch that into your calculator, it ends up that is equal to 0.0082 about. So you can see that it matches up with that probability. So if you look at the situation with now 4 people, and we're seeing all the different ways that at least 2 people can share a birthday, again, you're looking at pulling the groups of 2, then you're looking at pulling the different groups of 3. So just thinking about the number of choices, I guess I mean, we could write them all down. If like 2 of them share, we'd have like AB, we could have AC, AD, then I could take B with C, B with D, and B with A is already done. So then we could take C with D, and it's with all the other ones. So we have 6 already there, for that's just 2 sharing a birthday. But then it could be 3 share a birthday. So A, B, and C could share, or B, C, and D could share, or A, B, and D, or C, D, and A. I think that's 3 different options. And what these really are, if I want to make sure my counting's right, is choosing from 4, choosing 2. How many ways can that happen? Where the order doesn't matter, because if I have A and B sharing a birthday, that's the same as B and A sharing a birthday. And then this next one is 4, but choosing 3. And then lastly, we could have all 4 of them sharing the same exact birthday, A, B, C, D. And so right now, I think we're at 10, there's like 11 different things that could happen. So that could take a lot to try and calculate each of those little groupings. So let's calculate the probability that 2 people out of 4 share the same birthday by using the complement. So remember we said that if we're saying, okay, they don't share, not share, do not share. Oops. So if they don't share the same birthday, you have, again, the first person can have it. There's 365 ways that they can have their birthday. Then the next one would have to be counting down, 364, then 363, then 362. And so if we want to know at least 2 actually sharing one, it's just, again, that complement. And so if you notice what's happening, if we compare these, the 3 versus 2, we have this countdown, 365, 364, 363, and then it stops. Then the other one goes down to 362, and then the bottom is just a whole bunch of 365s happening. And so the pattern that I see is that if it's any size group, we're going to have 1 minus, because we are looking at these complements. Notice that for a group of 4, we have 365 written 4 times. For a group of 3, we have 365 written 3 times. So if our group is size n, we're going to have to write 365 to the nth power. That would get me that number of 365s. And then on the top, that should look kind of familiar. It is a countdown, but it stops. It's kind of like factorial, but it stops. That should remind you of permutations. That is going to be 365. We're going to look at choosing, though, n. And so you can see that this 365P4, remember that really means you're like kind of filling in 4 spots and you're counting down 365, 364, 363, 362. And so that's what's going to happen here. So the probability of n people sharing, or n people with at least 2 sharing a birthday, no, it doesn't really fit there, is going to be that. So in our class, we have about 30 people. I'm just going to go with that because 30 is a nice number. N equals 30. We're going to write that the probability of this happening is going to be 1 minus 365 p30 over 365 to the 30th power. When you enter that into your calculator, we get that this is about 0.706, which is really close. It's about 71%. So in a group of 30, there's a 71% chance that they would share a birthday. So what do you think? Would you make a bet that 2 people in our class share a birthday? I might, because 71% is highly likely that 2 would share the same birthday.